Your screen is online and it's your stage. Have fun, Martin.
Thank you. Okay, so hi everyone. So Nano and Mark gave us a very good overview of Azure DevOps. Now I want to give you a brief introduction about GitHub Actions, and I want to show you how we can use GitHub Actions to provision resources in Azure. Before I start, let me quickly introduce myself. My name is Martin Brandl. I'm working as a cloud solution architect at White Duck, where I'm also the head of our cloud operations and cloud development team. If you want to contact me, feel free to reach me via Twitter or LinkedIn. I do also have a blog where I post some Azure-related content. So if you want to check it out, you will also find an article there that will cover this topic a little bit deeper. Okay, so this is the agenda for today. I will start with a very small GitHub Action introduction, where I will cover the very basics of GitHub Actions. Then I want to show you how we can establish a connection between your Azure resources and your GitHub Action workflows. I do also have a demo prepared where we will provision some resources to Azure. And finally, I hope we will have time for some questions. Okay, so what is GitHub Actions? GitHub Actions allows you to automate basically any kind of process you have within your software development project. Probably the most famous example is the continuous integration and continuous delivery process, where you build your application and deploy it to any target system. But it can be anything else too, like you can, for example, create a ticket on a third-party CRM anytime someone creates an issue within your GitHub repository, for example. So just any process you want to automate. GitHub Actions gets executed based on an event that happens, for example, inside GitHub, like if someone pushes code to my repository. Or you can schedule GitHub Actions and say, for example, my GitHub action should run every day at midnight. Then similar as we saw in Azure DevOps, there are a set of hosted runner available for every major operating system like Windows, Linux, and macOS. And you also have the possibility to add your own self-hosted runner where you have more control over the installed hardware and software, of course. Then GitHub Actions comes with a built-in encrypted secret store. This is the place where we usually put all our credentials that are necessary for things like service connection to third-party applications. And finally, GitHub Actions are easy to write and easy to share due to the good marketplace integration. Okay, GitHub Actions are described as workflows. And a workflow is basically just a file that is written in YAML and is always located within the .github/workflows directory. The structure of a workflow is very simple. It contains one or multiple jobs. And one concept which is very important here is that each job will run on a separate environment. So why is this important? Because you won't be able to share state between jobs using the file system. But within a job, you have one or multiple steps, and these steps runs on the same agent, so you will be able to share information between the file system. I think that's the only most important part here to know. And finally, steps are a collection of actions, which are the smallest building block of a workflow. And an action represents an individual task, like, for example, the invocation of a PowerShell script, or as we can see here in the screenshot, the run of a CLI to build your application, for example. On the top, we can also see the trigger of the workflow. And on the next slide, we will see what kind of triggers are available. Basically, there are 3 types of events that can trigger a workflow. The first type is anything GitHub internal, like if someone raises an issue, or if someone writes a comment, or even if someone forks our repository, we can trigger our workflows. We can also define that our workflow gets triggered based on a schedule, which uses the cron syntax, as you can see in the screenshot. And finally, if we want our workflow to get executed based on any event that happens outside of GitHub, we have the possibility to use a webhook, or it's just an API call and invoke the workflow ourselves. Okay, then one thing I really like about GitHub Actions is are the community-powered workflows. Why? Because I think this will be the successor of GitHub Actions. GitHub Actions is kind of new, but there are already over 3,500 GitHub Actions available in the marketplace, which, by the way, is over 3 times more than Azure DevOps has, and Azure DevOps is out there for years. So I expect to find a workflow for almost any process I can imagine within the marketplace soon. And that's why I believe that GitHub Actions is the future of software automation. By the way, if you want to create your own action, you have 2 options to do that. The first one is using is writing the action based on JavaScript, which I would say is the native approach. And you're also able to write containerized actions. So basically, you have these 2 options. Both comes with pros and cons. A few words about pricing. GitHub Actions are completely free with unlimited build minutes, at least for public repositories. If you want to use GitHub Actions on private repository, you will have at least 2,000 free build minutes available. And depending on your license, you have up to 50,000 minutes, free build minutes available. But of course, you always have the option to buy additional hosted runner minutes. And as you can see in the picture here, the price is depending on the operating system. The macOS agent is 10 times more expensive than the Linux one. If you want to add self-hosted runner, they are completely free here. Okay, now let's talk about how we can connect GitHub Actions with Azure. So in Azure DevOps, there is a separate place where you can create so-called service connections to any external or remote services like Azure, for example. And then you are able to use these service connections within your pipeline. In GitHub Actions, you store the connection information within the GitHub secret store, and then you reference them within your workflows. So I think under the hood, both will work the same, but the naming is a little bit different here. Also, the user experience within Azure DevOps is much better in my opinion, because Azure DevOps has a graphical user interface where you can select your target source or target system, and then it asks you for the information that are needed to create a connection. And in GitHub, you just have a text field where you have to paste your credentials. And you have to know what format, which action needs the credentials. But for the Azure DevOps part, or for the Azure part, you do have 2 options to authenticate to Azure. The first one is using a service principal. This is the most common, and I would say the recommended way to authenticate to Azure. For those who do not know what a service principal is, you probably know what a user principal is. Like my user principal in our tenant is martin.brandl@whiteduck.de. And together with my password, I'm able to log in with my account. And so a user principal represents a person, but as you can imagine, I do not want the GitHub action runner to run with my account. So there's another concept which is called a service principal that represents an application. And the name of the service principal is called the client ID, sometimes the application ID. And the password is called the client secret. And with these 2 pairs together, an application is able to log into Azure and has an identity which I can grant access to and allow them, for example, to deploy to a resource group in Azure, which we will see later. And the second option is the use of a publishing profile. A publishing profile is basically just an XML file that contains some connection information and also gives you access to specific Azure resources. When I started working with Azure many years ago, there was no resource manager available, and the authentication using a publishing profile was very common. But nowadays, I would not use it, and I would definitely go with the first option. Okay, but I think that was enough slides, so let's go with a demo. And I have to share another screen now. Okay. So what we see here is a almost empty GitHub repository. I only added 2 files. The first one is the README file, where I described some prerequisites for the demo. So if you want to do the demo yourself, I hope I provided enough information that you are able to do that. I also added a cleanup part to ensure everything is clean after the demo. And the second file, what I have here is an ARM template. This represents Azure infrastructure, or let's say this is the infrastructure as code approach native for Microsoft. And in this example, I will deploy 2 resources. One is a web app, which is usually used for websites, for example, or to deploy an API. And the second resource is an app service plan. The app service plan is needed because within Azure, every web app has to live inside an app service plan. But the content within this template isn't that relevant. It could be a much more complicated example for sure, but then the demo would also take longer. So it's not about the content here. Okay, so we have our deployment file. Now what we need in Azure is a resource group, because within the resource manager, every resource in Azure lives inside a resource group. And as we can see here, the subscription is empty. So we need to create a resource group. And we also need to create a service principal that we will give access to the resource group in order that our workflow can deploy resources to it. And for that, I have a little PowerShell script, which I will just execute and then explain, just to save some time. The first thing it will do is it will create a resource group named GitHub Action Demo Resource Group inside Germany West Central. And then it will create a service principal with the name here, and grants it the contributor right to the resource group we just created. With using this switch here, we tell the Azure CLI to get an output that we can reuse for to authenticate against Azure. And we can see the output here. It's a JSON, which contains the client ID and the client secret, which basically represents the username and password of a service principal. So I have to copy this part here now, and I have to create a GitHub Actions where we paste the credentials. And the secret store is available within the settings module under secrets. Here we can add a new secret, paste our content, and we choose a value. Almost all demos are using Azure credentials, so I will stick to that. Okay, and now we have set up our, I will call it service connection, like in Azure DevOps, or at least we have our credentials available here. And let's check whether the resource group got created. Yes, that worked. And we will also check whether we have gave our access. Yeah, okay, so and our service principal has contributor rights to this resource group. So it should be able to provision resources in here. Now it's time to create an action, and this can be done using the actions module here. And we won't choose any predefined workflow. We will just set up it ourselves. And this is how the editor of GitHub Actions looks like. The first thing we need to do here is we can choose a different name for the workflow file at least, but I will stick to main YAML. But I do want to give the workflow a little bit better name. Let's call it deploy to Azure. Then we have to define the trigger. choose the event which causes our workflow to get executed. Right now, it will get executed on every push or pull request to the master branch. I think we can omit the pull request trigger, but I don't want our deployment to get executed every time someone just changes a line of code in the README file or something like that. So let's further restrict it to the Azure deploy JSON. So only if someone changes something within our infrastructure as code template, then this workflow should run. Then this sample contains only one job, which is called build right now. I will change it to deploy because it fits a little bit better what we want to do. And right now it runs on a Linux agent, which I'm fine with. Then we have 3 actions within our sample here. The first action will check out our repository and make it available inside our runner so that we are able to access the files. And this one is very important because we want to deploy an ARM template that sits inside our repository. We will need this this action, and that's why I will leave it. That's probably a common pitfall, I think. If you want to deploy something with GitHub Actions, ensure you have the checkout action in place. Otherwise, you won't be able to access file within your repository. And these other actions are just hello world outputs. We can safely remove them. Okay, now the first thing we need to do is we need to log in, or we need to authenticate against Azure. And to do so, there is an action that is called Azure Login within the marketplace. And if we click there, we can copy the necessary part in our clipboard, paste it here. Then we have to ensure we use the right amount of spaces because it's YAML. And oh, something I missed telling you is how the structure of an action itself. So an action can contain a name. If you omit it, it will use this string here in the output. But if you want a more user-friendly output, you should give it a name. And this concept is very important to know. You reference an action using the GitHub account name, then the repository, and then you can reference a release or a tagged release. Just to show you what I mean, if we go to the Azure Login action repository, we see this action lives within the Azure account. This is this part here. Then it's the login repository we are referring to. And I expect a release with this tag inside the repository. So let's go to release. And yes, we are basically, this action basically references these assets here. So that's the concept behind the actions, and that's why it's so easy to write our own actions. You just need a public repository, and everybody can use it. Okay, then within the with section, we can supply some parameters that this action requires. And for the login action, we need to specify our credentials that we put into the secret store, and we can reference them using $ double curly bracket secrets dot, and then the name of the secret we chose, which was Azure credentials. And the second parameter is optional. We don't need it because we do not need a connection to PowerShell. So now we have a login, or we have authenticate to Azure. The last thing we need to do is to use our template and deploy it to Azure. And to do this, there are basically 2 options. And when I started playing around with GitHub Actions, I tried to write different workflows for use cases I face in my daily business. And I was surprised that there was no, let's say, dedicated Azure Resource Manager template action available within GitHub. So I decided to write my own, and I will use this now. The other option would be to use the Azure CLI action. But this would require us to know exactly which kind of CLI command we have to use, and also which parameter is they require. So I want to go with the Azure Resource Manager. So with this task here, we also copy it to the clipboard, paste it here. And we also have to supply some parameters. The first one is the name of the resource group we want the template to get deployed, which is called GitHub Actions demo resource group. Then we have to specify the template location. It's an Azure deploy JSON. Then optional, we can choose the deployment mode. I will leave it with incremental, so we can just delete this one. Then we can choose a deployment name. To get a better output on Azure, I just provide a name here. And now we can provide parameters for the Azure Resource Manager template. And we have to check the template very quick. And indeed, this template requires 2 parameters. The first one is the name of the app service plan, and the second one is the name of the web app. So let's provide the parameters here. I will go with GitHub Actions demo ASP for app service plan, and web app name equals GitHub Actions demo app. Okay, this should be it. That should be the whole workflow we need to deploy the resources. So let's commit the files. Or the file. And because we restricted the trigger to only get executed if someone within the Azure deploy JSON changed, we also have to edit it here. Maybe we add a dot here, description. Commit changes. Okay, and if we go back to our repository, we should see the dot here indicates that an action runs now. And if we click there, we see it's the deploy to Azure action. And the first job that will run is the deploy job. Right now we are in a queue because we are using the free hosted agent. It can take a few seconds before the job will actually run, but let's go and check where we are. Okay, so it already started running. The first action already executed, so we have all our files available within the agent. The login was also successfully, and now the last action runs, which deploys the resources to Azure, and we can cross-check that. If we go to deployments now, we should see them here, accepted. This is, by the way, the name we supplied. I think it's good practice to choose a name, because then you see this deployment was executed by a GitHub action. And if you go there, we should see, hopefully soon, that the deployment will start and that our web app gets created. Let's go back there. It's funny, usually it just takes a few seconds, but okay, now. So now the app service plan gets created. And I see we get an error, service unavailable. No, okay. So the first resource should be there. Let's go to overview and refresh it.
As always, Martin, the demo god is with you.
Yeah, but I'm confident that this will run. No, not cancel. Refresh. Your deployment is complete, so it tells us everything is there, but it isn't. Okay, let's refresh the browser. The app service plan is there, but I'm missing the web app. Let's give it a sec. Funny.
I guess that one was the one with the arrow.
You might be right, but it should be still visible here. And no, it looks like our website also gets deployed. Okay, so let's go back, give it another try.
There it
Okay,
is.
here it is. And we will be able to query the website, and we will see the default welcome page. Hey, app service developers, that Microsoft gave us here. And also, if we go back to our action, we see that it completed now. And yeah, that's basically all from my demo. Ralf, I would give it back to you.
Well, if there are no questions, and it looks like the chat is empty, there are no questions in. Let me check if there are some following us still.
Yeah, sure.
Oh yeah, well, there are 30 people outside and watching our video stream here. So looks like you've explained it very well, so that there are no open questions anymore.
Hopefully.
Yeah, cool thing, I guess. Okay, cool. Thanks a lot
Okay.
for demonstrating and having that cool issue with us, which is
You're welcome.
that was really awesome to see it in action. Thanks a lot for that. Cool thing. So last but not least, right? It's up to me.
It's up to you.